So hi, hello and welcome. Microbehunter here. How fast are white blood cells? This is the question that I would like to address today. What you see here on my left side, this is indeed a white blood cell here right now. You're able to see it in your original speed. And you see it's not moving very quickly. All of those other disc-shaped cells that you see here, these are of course red blood cells. They're not able to move on their own, but those white blood cells, they like to crawl around inside of our body and protect us from disease, because what they do is they try to hunt down and catch bacteria that might have entered our body, and therefore they're protecting us from infections. And I received a question from one of my viewers, and I would like to share that question with you, because this question indeed is quite unique and also very interesting. And it's as follows: could you please further explain the speed at which white blood cells move? And if they were human-sized, how fast would they be? Well, I've got good news for you. This can be calculated, and it's not even that difficult. And I would like to show you how I've done that. But do not worry, I'm not going to do a lot of math now. If you want to see all of the steps of the calculation, of course, you can look into the description below. But I think I'm able to just explain you my reasoning without any formulas here. So this here is now a little bit in time lapse, and you indeed are able to see now that it's moving significantly faster here. It's 10 times faster than in original speed. And the problem now is well, how fast is the original speed? And for that you need a scale bar. So what I've done is I've taken a picture of a scale bar. I've got a so-called a micrometer slide, and I've superimposed that. And so now you see this white blood cell move along. Of course, I have to then measure the speed using its original speed, obviously. So this means that I have to take then the length of the original video clip. And what we see over here from line to line, from black line to black line, that's 10 micrometers. So over the course of this distance here, it's 25 micrometers, and the original time of the clip is 131 seconds. So right now it's of course much faster, but the original speed is just a little bit over 2 minutes. If you essentially now know the distance, it's basically 25 micrometers in 131 seconds. And if we do that math, you're going to get approximately, 0.2 micrometers per second. Okay, and so essentially you have to do a little bit. I've got a little cheat sheet here in front of me. It's quite less than a millionth of a meter per second. That's quite slow, right? But the real question is now is if the white blood cell had now my size, how fast would that be? So we got to scale it up. So the question is now, how many times larger am I compared to this little white blood cell here? So all you have to do is you have to divide my size by the size of the white blood cell. The white blood cell has approximately, over here we see it's approximately, it goes from this black line here, maybe to the next black line here. That's 20 micrometers. Let's just assume that it's approximately 20 micrometers in diameter. And if you divide now my size, 1.76 meters by the 20 micrometers, you're going to get a value of approximately 88,000 times. So this means I'm 88,000 times taller than this little white blood cell here. And then essentially all I have to do now is I have to multiply this 88,000 times by the 0.2 micrometers per second. So I'm just also scaling up the speed, the velocity of this white blood cell. And then I'm able to get a value of approximately 17 millimeters. It's about so much, 17 millimeters per second. And you know what? I even took a video of that, and I would like to show it to you. This is now me moving along approximately 17 millimeters per second. And if you kind of wonder how I've done that, well, it was a little bit of an exercise of my toes here. I've been inching along, so to say, with approximately 17 millimeters per second, and that would be the speed of a white blood cell if it had my size. Yeah, so you see, with a little bit of fantasy, you can calculate pretty much everything. And this speed, of course, seems to be very slow. It is very slow. but evidently it's enough for those white blood cells to actually protect ourselves. And as a matter of fact, when they're traveling along with the blood, of course, their speed is much faster. But when they're leaving the blood vessels, when they're moving through the body tissue to fight diseases, then basically they have to crawl along at that speed. And I think with that, I'm going to leave it at that. And as we marvel at nature and at the complexity of nature as well, I think I just can only encourage you to put samples under the microscope to explore your environment a little bit more, because there's so many new things to discover. I think I'm going to leave it at that for right now. I wish you all the best. Happy microbe hunting as always. See you around next time. Bye-bye.